What is up, kiddos? Last video for the year. Got applications of systems of equations and inequalities. So we're taking everything that we've been doing and we're just putting them in big, ugly word problems. But I promise they're not that bad. So the first one we got here is Mr. Madsen ordering some cupcakes. So it says, Mr. Madsen wants to order cupcakes to be delivered to his son's birthday. The Cake Baker Incorporated charges 75 cents per cupcake and $35 for delivery. Cupcakes R Us charges $1.15 per cupcake and $25 for delivery. What's the minimum number of cupcakes that Mr. Madsen needs to order from the Cake Baker to have a lower price than Cupcakes R Us? Well, the first thing we're going to have to do is make some equations, because we've got two places that he can order cupcakes from, which means we're going to have two equations. So the first one that we're going to make will be for the Cake Baker. And Cake Baker charges 75 cents per cupcake, and that keyword per, we know that whenever we're charging a price per something, it's going to be every time that we buy a cupcake. So my equation is going to be 0.75x for each cupcake. Then we also see $35 for delivery. Well, it's only going to be delivered one time, so we'll just add 35 to it. And then we're going to go ahead and call that y1 since we've got two equations. So this one's going to be y1. Obviously, our next one's going to be y2. So for our second equation, we need it to be for Cupcakes R Us, and we know that Cupcakes R Us charges $1.15 per cupcake and then $25 for delivery. So if we wrote that equation, it looks like this. So we've got our two equations here. And now the next thing I want you to do is go over to this table, and we're just going to add an extra line in here. So we've got our extra line. And so now what we can do is, since both of our equations are in the y equals form, we've got y1 equals and y2 equals, take a second and plot those on your calculator. And you'll notice whenever you plot them, you might not be able to see it. So whenever you go to change your window, let's go ahead and change your x max and your y max so we can see our lines. So an x max of 50 and a y max of 100, after you put those in, you don't need to change your scale. But after you put them in, you should be able to see both of those lines pop up, and there will be a clear intersecting point. And we know that when we have two lines that have an intersecting point, that's going to be the solution. But the question is not asking us for a solution. The question asks us, what is the minimum number of cupcakes that Mr. Madsen needs to order from the Cake Baker to have a lower price than Cupcakes R Us? So we're going to use this table, and we want to go ahead and label this one as X for cupcakes, and then we've got y1 and y2, and that's going to be for our total price for each one. And if you look at your answer choices, they tell you that it's either going to be 20, 24, 25, or 26. So I'm going to go ahead and put those x values in here. We've got 20, 24, 25, and 26. And so now let's go to our table on your calculator. So hit second table, and you might have to scroll all the way down to 20, 24, 25, and 26. And whenever you get that, go ahead and put those numbers in your table here. And now that we've got our table filled out, we can answer our question. So we can see that whenever we buy 25 cupcakes, it doesn't matter who they're from, but it would be the same price. But the question is not asking us when it's the same price. It says, what's the minimum number of cupcakes he needs to order from the Cake Baker to be cheaper than Cupcakes R Us? Well, we can see the Cake Baker, these ones in the purple, they're more expensive than Cupcakes R Us until you get past 25. So whenever we get past 25, you see that for 26 cupcakes, the Cake Baker is $54.50, and then Cupcakes R Us is $54.90. So we need to order 26 cupcakes in order for the Cake Baker to be cheaper than Cupcakes R Us. So our answer for that one is going to be D, 26. Now if we go down to the next one, it says the owners of a new restaurant want to spend no more than $1,000 for at least 10 minutes of advertising. The cost to advertise on a local television station is $200 per minute, and the cost to advertise on a local radio station is $50 per minute. The owners of the restaurant want to get the maximum number of minutes of exposure for $1,000 in both TV and radio. Which is the reasonable solution? The first thing you always want to do if you've got these big word problems is figure out what we're trying to find. So we've obviously got advertising on a TV station and then advertising on local radio. So let's do our let statement, and we'll say that let X be TV minutes and Y be radio minutes. So now we need to come up with our equations. Well, I'm going to start back at the beginning of this. It says the owners of the restaurant want to spend no more than $1,000. So if you think about those words, no more, they don't want to spend $1,001, they don't want to spend $2,000, they want to spend no more than $1,000. And if we write that as an inequality, then we would have something has to be less than or equal to $1,000, because again, we don't want to spend over $1,000. And for our other equation, we've got at least 10 minutes of radio. So we don't want to advertise 8 minutes, we don't want to advertise 9 minutes, we want at least 10 minutes or more. So if I wrote that as an inequality, we've got something that's more than or equal to 10 minutes of radio. Well, now we have to figure out what to put on the left side. If you look over at our variables from our let statement, we've got TV minutes and radio minutes right there. And so to fill out our second inequality, we can just say X plus Y, because our X is TV minutes and our Y is radio minutes, and so when you add the total minutes together, you get something that has to be more than or equal to 10 minutes. And when it comes to price, we can look back at our equation, or back at our, word problem, and we see that the TV is $200 per minute and the radio is $50 per minute. So we know that TV is X and radio is Y, so if we filled in our first inequality, we get 200X plus 50Y is less than or equal to $1,000. Now you can always graph these if you want to, but if they ever give you multiple choice answers that have both your X and your Y in them, then what we can do is plug them in. So for example here, we'll look at part A. You know that they've got 12 minutes on TV, and we said TV was going to be our X, and then 2 minutes on radio. Radio is our Y. We can just plug in our X and our Y for each answer choice. Well, if we take the first one, 12 minutes of television and 2 minutes of radio, if we have 12 for our X, well, 12 times 200 is going to be way over 1,000. That's going to be $2,400. And that already goes over our budget. So number one is going to be crossed off. So we can say goodbye, number one. And then number two, it says 3 minutes on TV and 8 minutes on radio. Well, if we plug that into our equation, we have 200 times 3 and 50 times 8. And that comes out to be exactly $1,000, so that fits in with our budget. So B works, but let's check the rest of the answers just to make sure. So we'll see that it says the owners can advertise 4 minutes on TV and 4 minutes on radio, but if you look at our second inequality, we want to do at least 10 minutes, and 4 minutes plus 4 minutes only equals 8 minutes. So we can cross that one off, and we can also cross off the bottom one because 1 minute of advertising is way less than 10. So our answer for that one is going to be B. And again, you can plug in the 3 minutes and the 8 minutes into our inequality, and it's the only one that satisfies both of those inequalities. Now let's look at number 3. At their last game, basketball team sold sodas and waters, which made a total of $151. They sold a total of 58 drinks, and if they charged $2 for each water and $3 for each soda, what is a reasonable conclusion that can be made about the number of drinks sold? Same thing that we did for the last one. The first thing we want to do is make our let statement down here. So decide what you want to call X and what you want to call Y. I'm going to go ahead and say X is soda and Y is water. And now it says we had a total of 58 drinks. Well, you know that you only had 2 types of drinks. You got sodas and waters. So if we make our first equation, we're going to have X plus Y has to equal 58. Because this is my sodas and my waters, and this is my total drinks. So we know X plus Y has to equal 58. Now it also says if they charge $2 for each water and $3 for each soda, what is a reasonable conclusion? Blah, 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 blah. Well, we know that each water is going to be Y and each soda is going to be X. So make sure you put each number that goes with their X and their Ys. So my second equation is going to be 3X plus 2Y. And we're talking about dollars now, so $2 and $3 each gives me a total of $151. So if we look at this problem, they didn't give us X's and Y's like they did in this one over here. All they gave us was conclusions. So what I'm going to go ahead and do is take these equations and graph them. And to graph them, we need to get them in Y equals. Well, it's easy to do with this top one. If I put that in Y equals, I end up with Y equals 58 minus X. And that one becomes pretty easy to graph. And now with this bottom equation, first step I'm going to do is subtract 3x from both sides, and then we're going to have to divide by that 2. And I'm going to skip a step here and jump straight to it and show you, but if we simplify that one out, we end up with y equals negative 3/2 x plus 75.5. So we have our two equations now, so go ahead and graph them on your calculator. And you can leave your window set up the same way from number 1 because it turns out that it helps us see this one too. But if you graphed them right, you should see a clear intersection point, and if we do the second trace and then 5 for intersect, you can hit enter 3 times, and then it gives you your intersection at the point 35, 23. If you didn't get that as your intersection, make sure you put this in right, and make sure you put that fraction in right there too, because that will be the part that trips you up. But we've got our intersection point, and we know that this is x and this is y. So if you look back at our let statement, we said that x is soda and y is water. So we sold 35 sodas and 23 waters. Well, if we look at our answer choices, we know that more water wasn't sold because water was y and 23 is less, so it's not D. Same number of waters and sodas were sold. Well, that's not true because it's 35 and 23. Those aren't equal. More sodas than water were sold. That's definitely true. 35 is more than 23, so that might be it. And then A is not right because we sold both sodas and water. So again, we solved those for y equals, then we graphed them, and then make sure your let statement was there, x and y's, and there's your answer. Very last one, we got Farmer Brown making an area for his chickens to roam. He has a maximum of 55 feet of fencing material to use for the enclosure. If he wants the length of the garden to be at least 3 times the width, what is the maximum width that will meet Farmer Brown's conditions? We've got some keywords here that we need to pay attention to. So we've got maximum of 55 feet of fencing material, and he wants the length of the garden to be at least 3 times the width. But first thing we want to do is always make a picture whenever you can. So we've got a nice area for our chickens, so let's make a picture of our fenced-in area for our chickens. So we've got our fenced-in area. We've got one gigantic purple chicken living in it. He's nice and happy. And it says we've got a maximum of 55 feet of fencing material. Well, if we think about what that means, if you're going to make a fenced-in area, it's all dealing with perimeter because it's just the outside of it. Well, if we talk about our perimeter, we know that we need to add all the sides together. And if we do that, we end up with 2L plus 2W less than 55. And the reason we use less than there is because it says a maximum of 55 feet. So this is the maximum we can have. So anything over here can be less than 55. And we'll go ahead and do less than or equal to, because it can be 55 feet. And then it says he wants the length of the garden to be at least 3 times the width. Well, that means if we write as an equation, the length of the garden, we know that at least means it can be greater than or equal to 3 times the width, which would just be 3W. So we've got our two equations here. And again, you could always do this as a graph and solve it for one variable and graph them. But if they give you answer choices like this, it's going to be a lot easier just to plug them in. And we know that these are all widths because it says what's the maximum width that Farmer Brown needs. So all of these answers over here are all your width. So your width equals all these. Well, let's plug them in and try it. If we start with a width of 6, if we take that 6 and plug it in over here, we know that 3 times 6 is going to give us a length of 18. So we'd have a length of 18 and a width of 6. If we plug that into our equation, we would do 2 times the length plus 2 times W. So 2 times 18 plus 2 times 6. And that gives us a fenced around total of 48. So that one definitely works. So let's check the rest of them. We've got a width of 7. If we have a width of 7, if we do 3 times 7, it's going to give us a length of 21. So if we have 21 and 7, and we plug that into our big equation, we would end up with 2 times 21 plus 2 times 7, and that gives you 56. And that breaks our rules. We can't have 56 because we can only have a maximum of 55, and even though that chicken wishes he could have a bigger enclosure, we can't do it. So 7 does not work, and since 7 does not work, you know 20 and 21 aren't going to work, so 6 is the final answer for that one. That is all that we've got for you. I hope y'all have a wonderful evening, and I will see you tomorrow in class.